children, same chapter, chapter 8 quadrilateral. We are continuing the theorem part. Theorem 8.7. If the diagonals of the quadrilateral bisect each other, then it is a parallelogram. So what is given here? A quadrilateral diagonal bisect each other. That means a quadrilateral is given. I'll write here given ABCD is a quadrilateral, or in quadrilateral ABCD, diagonal bisect each other. That means OA equal to OC and OB equal to OD. Now what should be proved? It is a parallelogram. So to prove ABCD is a parallelogram. I think question is clear to you. This time quadrilateral is given. We have to prove that it's a parallelogram. Proof. Already the diagonal bisect each other, so we are taking the triangle OAB and OCD, the opposite triangle only we are taking. In triangle AOB and triangle COD, right? OA equal to OC, OB equal to OD. It's already given in the question. Diagonal bisect each other. OA equal to OC, OB equal to OD. Now we got these two sides only, because one triangle only we should check. So the first side we have taken as a OA, second equal side we have taken as a OB. So what about this included angle? Third side we are not taking because we have to prove that it is a parallelogram. So it's a quadrilateral. Can we go for this angle? Yes, we can go, because it's a vertically opposite angle only. So we will write here angle O equal to angle O, vertically opposite angle. This angle is the included angle only, right? This angle is the included angle. Therefore, the triangle AOB is congruent to triangle O only correspondence direct. So A for C only, it will be COD. The criteria is SAS. The criteria is SAS. Now I'll go for the angles. Now see, angle OAB, if I am writing here, what is the correspondence angles? OCD, CPCT. Similarly, one more angle I can write, angle OBA. Angle OBA equal to angle OD. Angle OBA equal to angle ODC. Okay, now what is the criteria here? Again CPCT only. By this, what is the conclusion? See the figure and tell me. That is OAB, the angle OAB equal to OCD we got. These two are alternate interior angles only. And similarly OBA also, if you consider, this is also one of the alternate interior angles only. By the CPCT we are getting the pair of the alternate interior angles are equal. Therefore these two lines are parallel. So this shows that this implies alternate interior angles are equal. Alternate interior angles are equal. Therefore AB parallel to CD. Similarly, we have to consider these two opposite triangles, which are the BOC and the AOD, and we can prove that also congruent only. These two triangles also congruent only. By this, what we can prove? Another pair of opposite interior angle, alternate interior angles are equal. Therefore, we can say that AD parallel to BC also. By considering which triangle? Triangle BOC only. I'll take triangle BOC is congruent to triangle DOA. Similarly, the criteria will be SAS only. We can prove that SAS. Again, by using this, we can prove that AD parallel to BC. So two pair of opposite sides are parallel. Therefore, the ABCD is a parallelogram. Two pair of opposite sides are parallel. Means using 1 and 2. Therefore, ABCD is a parallelogram. I repeat. We have given that the quadrilaterals diagonal bisect each other. So OA equal to OC, OB equal to OD. By using this, one more angle is required, which is that angle we have taken. So angle O equal to angle O, vertically opposite angles. Therefore, triangle AOB congruent to triangle COD, SAS criteria. Therefore, angle OAB equal to angle OCD, angle OBA equal to ODC. So by CPCT only these two angles. If you check the diagram, these two pair of angles are alternate interior angles only. So the given lines are parallel, AB parallel to CD. Similarly, we can prove the other pair of this side, that is AD parallel to BC. Now we got two pair of opposite sides are parallel. So what is the conclusion? ABCD is a parallelogram. So we have proved all the properties of the parallelogram as a theorem only. That means we as a definition we have studied that two pair of opposite sides is parallel, but later we have proved that opposite angles are equal and opposite sides are equal, diagonal bisect each other. And converse also we have proved. All the theorems proof you have to study. Now we are doing the examples. In this chapter, quadrilateral, no deletion for this corresponding current academic year, and moreover all the questions are important only. So each example also I will explain. The first example, show that each angle of a rectangle is a right angle. Show that each angle of a rectangle is right angle. That means rectangle is given. We have to prove that all the angle equal to 90 degree. So given is ABCD is a rectangle. A rectangle ABCD. To prove angle A equal to angle B equal to angle C is equal to angle D equal to 90 degree. All the angles equal to 90 degree only. Now here one point we have to remember that the definition of the rectangle, while learning the definition of the rectangle, we already told that in a parallelogram one angle is 90 degree. That concept we have to apply here. So the definition of the definition of the rectangle says that of a rectangle says that in a parallelogram one angle is 90 degree. Let us take angle A equal to 90. Right? So this part is already given in the question. So angle A equal to 90 degree. So we got angle A equal to 90 degree. By the definition of the parallelogram, we know that the properties of the parallelogram, opposite angles are equal. If angle A equal to 90 degree, therefore angle C is equal to 90 degree only. What is the reason? We can write that it is an opposite angle property. Okay. Next we can say that angle A plus angle B is equal to 180. What is the reason? Co-interior angles are supplementary. That means angle A is 90, therefore angle B equal to 180 minus angle A. So it is equal to 180 minus 90. Again B is equal to 90 degree. Again angle B equal to D by the concept of opposite angles of a parallelogram. So it is equal to 90. The opposite angle. So what we can say about all the angles? Angle A equal to angle B equal to angle C is equal to angle D equal to 90 degree. So when we are saying that it is a rectangle, we should go for the definition of the rectangle. What is the definition of the rectangle? Says that one angle is 90 degree. So by that we can take that angle A equal to 90. Therefore angle A equal to angle C we can write. Why? Opposite angles of the parallelogram. So angle C is also 90 we got. Now what is the next concept we can go for? That Angle A and angle B's sum is 180 degree because co-interior angles are the 180 degree. Here it is a rectangle, we told. All the rectangles are the special type of the parallelograms only. So the all the properties we can use whatever it is there. So A plus B equal to 180 degree means B equal to angle B is equal to 90 degree. Next we can use the same concept. Opposite angles are equal. So angle B and D are equal, therefore both equal to 90 degree opposite angle. That means angle A equal to angle B equal to angle C equal to angle D equal to 90 degree. So we can say that each angle of a rectangle is right angle. So all the angles 90 degree, hence proved. Example 2, show that the diagonals of a rhombus are perpendicular to each other. Means diagonal, the rhombus, it is given, a rhombus is given and its diagonal are perpendicular to each other. So we have to prove that angle O equal to 90 degree. We have to prove that angle O equal to 90 degree. See, first thing is that first point is that it is a rhombus. Rhombus means it's a special type of the parallelogram. So whatever properties we have learned for a parallelogram we can use. I repeat, what are the properties we have learned for a parallelogram? First thing, it is a definition only, that is two pair of opposite side is parallel. Next we learned that two pair of opposite sides are equal. Again we learned that two pair of opposite angles are equal. Then one more property, that is diagonals bisect each other. In addition to that, we can write that co-interior angles are supplementary in a parallelogram also. So all these points we have to keep in mind, then only we can prove this type of the questions. And quadrilateral is not easy to remember always because each question the proof is different. The second question, show that the diagonals of a rhombus are perpendicular to each other. So given ABCD is a rhombus. If it is a rhombus, what you can write about the side? All the four sides are equal. So let us write that AB equal to BC equal to CD equal to DA. I can mark in the diagram AB, BC, CD and DA. Now we have to prove that angle O equal to 90 degree. So we will consider these two triangle. These two triangle means AOD and a COD. So to prove angle O equal to 90 degree, proof. I already mentioned the triangle name. In triangle AOD and a triangle COD. Let us see what are the equal parts. Already we have marked the four equal sides. So in AOD which side is coming? AD, and COD which side is coming? CD. That is given because the rhombus criteria, right? Now OD equal to OD common only. Okay. Now what we can write? The third side, second side, what we have taken? OD equal to OD. So we got two sides. Now for getting the third side, what we can write? Let us see the diagram AOD. So first side we marked, second side we have marked. What you can say about OA? OA equal to OC. If I marked, whether we are wrong, we are not at all wrong because it says rhombus. Rhombus is a special type of parallelograms. I already mentioned that all the properties of the parallelogram we can apply. So OA equal to OC. So we can write the reason, diagonals of the parallelogram, or we can write diagonals bisect each other. Therefore, triangle AOD is congruent to order. See that O is common in second and third criteria. Here also O is common, so O equal to O only, right? Now O is gone means which letter is remaining? A. A is having correspondence with the C only. So what is the name of the triangle? Triangle COD. Now criteria, all the three sides S, S, S. Right? Now what we have to prove? Angle O equal to 90 degree. So let us take that angle AOD, what will happen? AOD equal to COD, that is CPCT. Equation number 1. Angle AOD equal to angle COD equal to CPCT, equation 1 only. Now we can write angle AOD plus COD equal to 180. linear pair, right? Because it is a diagonal only AC, so we can write that angle AOD plus COD equal to 180 degree. By using one, AOD and COD are equal, so AOD plus angle COD equal to 180. I will change as AOD only, okay, 180 degree using 1. So 2 times of angle AOD equal to 180. This shows that angle AOD equal to 90 degree. If angle AOD is 90 degree, we can write that angle COD equal to 90 degree. So we got this angle is 90 degree, means OD perpendicular to AC we can write it. So the diagonals perpendicular to each other. Angle AOD equal to 90, angle COD equal to 90, hence proved. I repeat the theorem. What is given in the question? I repeat the theorem. I repeat what we have seen, that a diagonals or the rhombus perpendicular to each other only the question. So the rhombus is given and we have to prove that angle O equal to 90 degree. So since it is a rhombus, all the four sides are equal, and for proving angle O equal to 90 degree, we are taking the adjacent triangles this time, AOD and COD. In that, AD equal to CD, OA equal to OC only. So we have got three sides, right? AOD, OA equal to OC, which property? Diagonal bisect each other. OD common. AD equal to CD, that is the first criteria we have taken, that the sides of the rhombus. By these three sides we have taken, so SSS criteria, these two triangles are congruent. Triangle AOD congruent to triangle COD. What about angles now? Angle AOD equal to angle COD, CPCT equation 1. Now if the AC is the diagonal, so what is the sum of these two angles? 180 degree. Since only two angles are there, linear pair we can apply here, and moreover AOD and COD are both equal, so AOD plus AOD equal to 180 degree. So 2 times of angle AOD equal to 180 degree, therefore angle AOD equal to 90. So if AOD equal to 90, what we can say about the COD? COD is also equal to 90 degree, hence proved. So what we learned from here, the diagonals of a rhombus perpendicular to each other, that shows that OD perpendicular to AC, or we can say AC and BD are perpendicular to each other. So I have proved examples here. Each exam is very important, and once again I am repeating, practice more, because it's very difficult to remember. With this, today's class I am winding up. Thank you.